Our learning target for today is that you can solve trigonometric equations with algebraic techniques. If you know your trig identities, using your basic trig identities, you'll be able to solve equations. Before we were doing trigonometric proofs, some of you were confused. You were trying to solve because you weren't here that day, and I said, no, you have to start on one side. You're trying to show that this stuff over here is exactly equal to this by using identities to get to that spot. When we're solving equations, though, we can move things from different sides. We can divide, we can subtract, we can still use our trig identities to change things if we need to, but it's easier, a little bit easier to solve. So when we're doing this, though, we need to consider a couple things. As we go to analyze solutions, we need to consider the period for each of our main trig functions. So the period for sine is what? Oh, please work. Periods for sine is, what is the period? It goes
0 to 2 pi.
It's 2 pi, 0 to 2 pi. For cosine is, no, that would be sine if we're doing the inverse. 0 to 2 pi. And for tangent, the period, it is, but how long is it though? Just pi. Pi. So I really have 2 pi, and pi. Now, unlike just regular inverses where I just asked you to evaluate what is sine inverse of square root of 2 over 2, or cosine inverse of square root of 3 over 2, or tangent inverse of 1, where we had to restrict the domain so that there would only be one output. We're looking at it as a function. We're going to be talking about our unit circle. We're going to try to stay within the unit circle, okay? Which means for sine and cosine, the first value we're going to worry about finding, or there's actually more. We have to go all the way from 0 to 2 pi to find all the values that work. There will be more than one. And then we have to write an equation to say, hey, this curve, this oscillation keeps going. So it happens as you do many revolutions, either in a positive or negative direction. For tangent, though, tangent's period is half of sine and cosine, so I only have to go from 0 to pi to evaluate it when I'm trying to find my answer for x. So we're going to consider the equation cosine x equals 1/2. And I know normally if I said, hey, what's cosine inverse of 1/2, there would only be one value, okay? Because there's one specific value assigned to that for it to be a function. But we're not looking at what's cosine inverse of 1/2. We're trying to find every value of x that has an output of 1/2. It's like solving the quadratic. There can be more than one solution. So when I go to solve this, I'm going to still look at my unit circle, which I have over here. I'm not sure what your conversation's about, but it needs to end now. If you have a question, raise your hand. So I'm going to look at my unit circle, and I have cosine of equals 1/2 on my unit circle in two places. It's going to be positive in quadrants 1 and 2. Right, Lindsay? Right. So that's going to be, actually not quadrants 1 and 2, quadrants 1 and 4. So cosine is 1/2 at pi over 3 and at 5 pi over 3. So that's where x equals pi over 3 and where x equals 5 pi over 3. We're kind of doing the idea of the inverse, but we're not treating it as an inverse function where it has to have one output. We're treating it as it's going to keep revolving around. What are all the values that will work for it? So if I look at this, that means that every time I revolve around and hit either one of those spots, I'm going to get that as an answer to my equation. It'll be a solution to this equation. So I need to add to this 2 pi, or 2n, 2 pi n, where n is an element of the integers.
Wait, why are we doing that? Oh, period.
Because it's going to, like, if I revolve around this, one revolution is 2 pi.
Oh.
So if I'm starting here, then you go 2 pi more units, and now I've hit that same value for cosine.
Okay.
Or if I go backwards 2 pi units, I'm going to hit that same value as an output for cosine. And the same thing with 5 pi over 3. n is an element of the integers. Where, I can't turn it off. All right. Any questions on that? So it's kind of like the same idea when we were writing the equations for the asymptotes for tangent, where we said, hey, yeah, the first one happens here. I think what was it? Pi over 4? No. Pi over 2. Pi over 2 was where it happened. And so we said, but it's just going to keep happening every pi units at that value. So we had to put that down. All right, solve each equation. We have, there's an equation, you look and go, yikes. But we're not doing a trig identity proof. We're past that. What we're doing is we're solving. So I'm going to subtract 2 sine x minus 2 sine x from both sides. Now I have 2 sine x equals the square root of 2. And I'm going to divide by 2. And I have sine x equals square root of 2 over 2. So I'm really saying what value of x would make sine equal square root of 2 over 2. I look at my unit circle, remembering that it's 2 pi for its period, so I got to go around the whole circle. That would be in quadrants 1 and quadrants 2. That's going to be at pi over 4 and 3 pi over 4. So my final answers for this one is, pi over 4 plus 2 pi n, or 3 pi over 4 plus 2 pi n, where n is an element of the integers.
Those are the places where sine is.
Those are the places where those are the angles in radians where sine is going to be square root of 2 over 2 for all possible revolutions in both a positive and negative direction. Yes.
So writing all of them, or do you want just
So you're going to write all of them by adding the plus 2 pi n.
Yeah,
Okay.
so you find each like possible integer and add 2 n.
And add 2 pi n. Yes. Yep.
Could you subtract 2 pi n? Could it be like plus or minus?
The n, since it's an element of the integers, will include negative multipliers, negative counting numbers that are multipliers. So we've got that covered by just putting a plus there. All right, so give letter B a try. See what you come up with. Cosine. We'll get there in a second. Just set it up first and ignore the 2x. Pretend it's x for now. See what you get. And we'll go from there. You're going to leave the 2x in there because you got to get rid of that after you find the angle. Because what is the x? The x is theta, or angle, in radians. And this is 2 times the angle. So we got to figure out what 2 times the angle is first, and then we can find the actual angle. Find your, just solve it like it's just x. Yeah. Actually, you guys, never mind, since there is only 2 sides on the page, you won't need a sheet of paper. We're good. There's not another copy, you don't have to write anything down. How are you doing with this, Mr. Deck? You guys have an answer yet? All right, you're not supposed to have phones out, guys. You don't need them right now. I will take them. I will write you up for it. Put them away. Short enough lesson. You're going to have time in a little bit. So make sure your phones are put away right now. What? For geometry. All right, here we go. 2 cosine of 2x. That's inside the cosine function, so I can't do anything with that yet. Equals the square root of 3. When you divide by 2, yes, cosine of 2x equals square root of 3 over 2. So you're treating this as your angle right there. Now it's not going to be your final answer, but the angle is 2x right now. So where does that angle happen to be square roots of 3 over 2 to give us?
Pi over 6 and 11 times.
Yes, for cosine, pi over 6 and 11 pi over 6. So what we start out with is, hey, that happens at pi over 6 and 11 pi over 6. But that's not what x is, that's what 2x is. So now I have to solve for x by dividing by 2 or multiplying by 1/2, giving me pi over 12 plus 2 pi n, or 11 pi over 12 plus 2 pi n, where n is an element of the integers. And I like to box my answer, but it's not being boxed. Questions on how we got that?
So you didn't divide by 2, or you counted by 2?
No, I did divide by, well, dividing by 2 is the same as multiplying by 1/2. Yep. Now I have to be careful with the next problems. Why?
Because it only goes up to 1 pi.
The period only goes to 1 pi. Because what's going to happen on the other side of that unit circle, if I've evaluated it here, if I add pi units, it'll happen over here again, or if it was here, it'll happen over here again. So I don't have to evaluate it on the whole unit circle, I just have to evaluate it from 0 to pi. And then add my, am I going to do plus 2 pi n? What, plus what?
Pi.
Plus pi n is what we're going to have once we have our angle. Okay? So on this problem, to solve for tangent, right now I see it's tangent squared. Some of you are thinking, oh no, we have to use 1 minus secant squared. We'll get there, but not yet. Right now I have one trig function. I'm happy if I have one trig function, because I can find that on the unit circle. But I am going to have to get rid of the squared. So first I add 4. 3 tangent squared of x equals 1. Divide by 3. Tangent squared of x equals 1/3. Well, there is no tangent squared on the unit circle, so I need to get just tangent.
Square root it.
Take the square root. Tangent of x equals the square root of 1/3, or the square root of 1 over the square root of 3, which is really square roots of 3 over 3. So I need to find the angle x that has an output of square root of 3 over 3 for tangent. Yes?
How did the square root of 1/3 turn into 3?
Square root of 1/3, square root of 1 over square root of 3. Square root of 1 is 1. Rationalize your denominator. Square root of 3 over 3. Kind of forgot. It's been a while, right? So much time bogged down in identities. All right. So that happens either at pi over 3 or pi over 6.
Pi over 6.
It's pi over 6. Because 1/2 times 2 over square roots of 3 would give us the 1 over square roots of 3. So pi over 6 is the angle where that happens. And it's going to happen another place on the unit circle, but I don't have to worry about that because as long as I've evaluated from 0 to pi, you guys have to stop talking. It's ridiculous. If not, you can spend a detention with me this week. Plus pi n, where n is an element of the integers. Any questions on how we got that answer? Try this for letter B. See if you can find out what value of x you would have for letter B.
Pi over 6 is the only one. There's not 2.
On that previous problem, pi over 6 is the only one because from 0 to pi, because we're in tangent. If it's tangent or cotangent, we
Only goes
because it's going to repeat over here when we hit the plus pi n.
Right.
Yes.
Why is there 2 answers for them on the top but not 2 answers for the other?
Because when we have sine and cosine, their period is from 0 to 2 pi. And they don't, like, if you look at tangent, if I do plus pi, I end up over here, it's the same value. If I do plus pi, I end up over here, it's the same value. But for sine and cosine, sine's positive here and here, and negative here and here. Cosine's positive here and here, and negative. I can't do the plus pi. So I have to find the both values on the unit circle and then add 2 pi. Yes.
Are we allowed to use, like, are we gonna be able to, have x as a unit circle,
You'll be making one that you'll be able to use on your assessments, yes. But right now you guys have yours from before, right? You still have it from your old notes.
Because you,
if they needed to use a reciprocal identity. Do you have to do that? If you have your unit circle, how do you find cotangent? Cosine over sine, or x over y, right? Yep, either one of those. But if you'd rather use tangent, yes, you could use the reciprocal identity. It might help. So this was 3 divided by 3 is 1, so you had cotangent squared equals 1. By the way, if you use this reciprocal identity, it would be tangent squared equals 1. Is that what you guys got so far?
Yeah. Square root of.
Okay, even if you didn't, you got cotangent squared equals 1.
Yeah.
So cotangent of x equals, oh shoot. I took the square root, and I did it in the last problem, so I screwed up, because guess what? When you take the square root in solving, you have a plus or minus. So this is plus or minus 1. So we got to go back and add an answer to the other problem. Only because we took the square root and I forgot about it. Can't believe, right here, there's supposed to be a plus or minus. So I should have known better, but it's a common mistake. I don't usually make it, but I did today. All right, so where's cotangent, or even tangent for that matter? 1 and negative 1 would be at pi over 4 and 3 pi over 4. So this would be, the positive answer would be pi over 4 plus pi n. And the negative 1 would be at 3 pi over 4 plus pi n. Yes?
If you wanted to find tangent, so it's easier, can you just flip it?
Well, since it's 1 over 1, you just flip it. It's the same thing.
But for like something like
If it was square root of 3 over, if it was square root of 3 over 1, then yes, you would just flip it and you'd know that that's. All right. This one, I missed the negative. So tangent would be that at 5 pi over 6. So we do have to add an answer to this. 5 pi over 6 plus pi n. Now, if I hadn't had the squared, how many answers would I have had? 1. But because I took the square root, there's the plus and the minus on that. Yes?
So are you sliding the other one, or just doing like the opposite on the other side? Or?
You can. Yeah, for tangent, you can just come right over here. Yes. Yeah. That's not what I wanted. Go away. Uh-oh. No. All right. No. Okay, I'm gonna have to go to my computer. All right, let's look at these bottom problems. I don't know what this is doing. Whatever. Where is it? Thank you. Awesome. Nope. Oh well, we tried. We can still see. Find all solutions to this equation from the interval from 0 to 2 pi. Do I need to add the plus 2 pi n on this? No, because they're giving me a specific interval. If they leave it open as find the solutions for x, well, there's infinitely many. I have to add that plus 2 pi n on sine or cosine. And if it's tangent, obviously add plus pi n. All right, we do have a problem here, though. Oh, man, it's a good thing you guys know your trig identities. Because do I have just one trig function? No, I have 2. But that's okay, because...
Divide by cosine. What do you mean you have?
Oh, I don't know that you can divide by cosine, because that would be like dividing x squared by x, right? Because there's an x in that cosine. I can't do that.
There's an x and x.
I could move everything to one side. You can't divide though, guys, because watch. If I have x squared equals x, can I just divide by x? Would that give me my solution to the quadratic?
X equals 1.
No. Because, look guys, that would give me x equals 1.
Yeah.
That's only one solution. I've eliminated the other solution by dividing.
That's okay.
Watch. X squared minus x equals 0. What was the other solution to this? Not just 1.
Negative 1.
It was 1 and... Oh my gosh.
1 and 1.
Seriously. These two things multiply to 0. So either x equals 0 or x equals 1. By dividing by something, a function that has x in it, like cosine sine or x squared divided by x, you eliminate some of your solutions and you're going to miss possible solutions. So we can't do that. What we can do, though, is do what we just did here. What's that? It's one of the F's of mathematics. Factor. So let's get it to the other side, just like we did with quadratics. And, no, not fractions or functions, although we are working with functions. So we have 2 sine cosine x minus square roots of 2, that's a minus sign, minus square roots of 2 cosine x. I'm going to factor out the cosine of x, leaving me with 2 sine minus square roots of 2 equals 0. I actually don't need my trig identity here. We will on some of the other ones. Because now I have, just like I had when I factored the quadratic, the product of 2 factors that are both equal to 0. Like, because of zero product property, either cosine x equals 0 or this equals 0. That's going to give me more than one solution.
Wait, what?
Wait, it's minus.
Is that that's a minus? Sorry, it's supposed to be a minus. It didn't show very well.
How did he just do this?
Any questions on what we've done so far? I'm not done. I'm not done. I have to solve both of these now separately. So I have to say, oh, cosine is 0. That's easy. Cosine 0 at pi over 2. So this gives me a solution of pi over 2. Now, is there any other place that cosine is 0? 3 pi over 2. So I have to include 3 pi over 2. Now I'm not putting the plus 2 pi n because they gave me the restricted domain to 1 unit circle from 0 to 2 pi. So that's 2 of my answers. Yes?
So even if it's tangent, you still go from 0 to 2 pi?
Yes. Because I'm not adding the plus pi n to hit all, I'd have to hit the rest over within that unit circle. Yes. Even if it was tangent, you'd have to go from 0 to 2 pi. All right, on this one's factorable. If you're like, I don't see it, then you can change sine to like a variable like y, 2y squared plus y minus 1. Oh, I didn't finish it. Sorry, thanks. Add square root of 2, divide by 2. You have sine equals square root of 2 over 2. Because this was a minus sign, so I added the square root to the other side, and then I divided by 2. So sine equals square root of 2, sine of x equals square root of 2 over 2. And so on the unit circle from 0 to 2 pi, that happens at pi over 4 and 3 pi over 4. So there are our 4 answers for that problem. So if it involves more than one trig function, it may require us to factor. Or if it involves something that has the same trig function where one of them is squared and one of them is not, it will require us to factor. When we get down to number, we'll see on that one too. Yes?
For when you got the square root of 2 over 2, you divided the 2 that was on the left of the sign, right?
Yes.
Why wouldn't that be negative square root of 2 over 2? Because it's a minus 0.
It was minus here and I added it to get it to the other side. So 2 sine minus square root of 2 equals 0. I added it first. Now, if I were solving it, if I took the square root to undo a square, then I'd have a plus or minus. But since I'm just simply adding it back to the other side, it's positive, and I just divide it by 2. Yes? Okay. On the next one, if you don't like working with sign, you can change sign, give it a variable name, it'll work better. Just a substitution trick. This becomes 2 sine, this is sine, that multiplies to 2 sine squared. We have 1 and 1. I need the 2 to be positive for the middle term to be positive, and then this one can be negative. So I have my factor. How did I get that? It will be because it won't be equal to 0. Like if there wasn't that minus 1,
Oh, I see.
just like in the case of x squared plus x equals 0, then I can factor out the x. But if it's x squared plus 2x plus 1, I can't factor out the x. I have to. Okay? So this gives me, by the way, if you don't like working with sign, call it this. Let y equal sign. You've got 2y squared plus y minus 1 equals 0. After you factor it, just replace the y's with sine, and you're in the same spot. So this means that if I add 1 and divide by 2, this one is going to be sine of x equals 1/2. This one's going to be sine of x equals -1 because I'd subtract 1 from the 0.
I think I'm working down the VA.
I did factor it. I don't want to FOIL it. I don't want to distribute because I'm trying to separate them so that I can solve. It's like solving a quadratic. I have x squared plus or minus x plus a constant. So to solve it, I need to factor or use the quadratic formula, which we could do. I wouldn't recommend it with sine. If it's factorable, that's just easier. All right, so we have where is sine 1/2? Sine is 1/2 at pi over 3, and no, it's not. Sorry, pi over 6 and 5 pi over 6. Bless you.
Is there only one spot?
Sine is -1 at only one place at pi. Yep.
No. Oh, this page is 2. No, isn't it? It's
No, that's cosine. Oh my gosh. Sorry, 3 pi over 2. But there is only one. I'm looking at the wrong numbers. I know what sine and cosine. All right. What am I going to need to do for letter C? Subtract. So I've got 2 sine x cosine x minus square roots of 3 sine x equals 0. I'm going to factor out the sine, leaving me 2 cosine minus square roots of 3 equals 0. Now, as long as my factors only have one trig function in them, I'm okay to set them equal to 0 and solve. And they do in this case. So this one becomes sine of x equals 0, which has a solution at 2 places, at 0 and pi. Yeah, you probably should do 2 pi also because it's including 0 and including 2 pi. So yes, 3 places. And then, bless you. If I set this one equal to 0, I'm going to add the square roots of 3 to the other side. I'm going to divide by 2. So places where cosine of x is square roots of 3 over 2. On our unit circle is pi over 6 and 11 pi over 6. So there's our 5 solutions.
Is it not negative?
It was negative. I added it to get it to the other side.
Okay.
Now, if I had taken the square root, then it would be plus or minus, and I would actually have 4 answers for that, for just that piece. This next one, lots and lots of fun.
Oh boy.
It actually took me 2 attempts to get it, because I just tried to do regular factoring the first time. Okay, why isn't the eraser working? Oh man. I just want to be able to see the problem. All right. No, don't want that. I can't just factor out a cosine because it's not equal to 0. So whenever we're trying to factor to solve, we got to get it equal to 0. So I actually have 4 cosine squared x plus 2 cosine x minus 2 square roots of 2 cosine x. I'm going to run out of room. Minus square roots of 2 equals 0. So how many terms do I have?
4.
4. When you have 4 terms and you're trying to factor, and it can work with 3 terms also, you have to do factor by grouping. But you got to get the grouping right. And I think it actually works out the way it is. If it's not, then we kind of switch the middle terms and play with it until we get to work. So when I used to teach Algebra 1, I tell them that there's one way to factor for binomials, another way for, we called them the 2-legged animal. The trinomials were the 3-legged animal, and the ones that have 4 terms were the 4-legged animal. And to kill the 4-legged animal, you have to cut it in half first. Yeah.
Do you, like, subtract the square root of the 2 over, and then, like, if you factor out a cosine, just have the denominator, and that'd be like, so it's square roots of 2
I have it divided by cosine, then I have a problem in that I now have a rational function in addition to everything else, so I don't have nice clean factors to solve with. So yeah, this would be the best way to handle this, get it to one side and try to factor for now. So if I do this, I'm gonna have cosine, 2 cosine, okay, by 2 cosine plus 1. And on this side, I'm going to factor out negative 2 and square roots of 2. No, just negative square roots of 2. I should have kept the x. I'm sorry. It's a shortcut I was taking when we were doing trig identities. The x is still there with the cosine. The x is with the cosine. And then this one, I can only factor out the negative square roots of 2, which leaves me with positive 2 cosine plus 1. So is factored by grouping going to work?
Can't you pull out?
Yes.
Oh.
It will. Why does it work?
What is?
Because this and this are the same. And there's a subtraction sign here. So now I can factor these two. Here's a term. Here's a term. Of these two terms, I'm going to factor out 2 cosine x plus 1. And then the other term, that's the terms that are left when I pull those out, is 2 cosine x minus square roots of 2.
That's all.
I want to leave it there for a second. Any questions on how we got that?
Is that it?
Yes.
So it's not like, okay, it's 2 cosine, so it's not cosine squared root of 1.
No, yes, because I was splitting, I was saying, hey, look, cosine will divide out of both of those. That leaves just a cosine there for the first term. And then I did the same thing here. I was just doing the greatest common factor of these two. Well, the greatest common factor is 2 cosine plus 1. Factored that out, I'm left with 2 cosine x minus square roots of 2. All set? There's a copy right here. Okay, so now we're ready to solve. We have, we're going to set each of these equal to 0. So 2 cosine x plus 1 equals 0. 2 cosine x minus square roots of 2 equals 0. We're going to add and then divide. So this one will be cosine of x. This one is subtract and divide, equals negative 1/2. This one will be cosine of x equals positive square roots of 2 over 2. Each of these on the interval from 0 to 2 pi should give us 2 answers. So cosine of negative 1/2. You're right. 2 pi over 3 and 4 pi over 3. Now what if that wasn't an x? What if it was a 3x in there? I divide these or multiply 3 or multiply them by 1/3. All right, and then, come on, technology work. All right, square root of 2 over 2 is pi over 4 and 7 pi over 4. So there are our 4 answers to this trigonometric equation. That's all we're doing for today. We'll do the other parts tomorrow. So your practice tonight from page 331 is 1 to 18, and you can actually start that. You have time in class today to get a significant portion of that done. Page 331, 1 to 18.
I'll get those.
Nope. I wish, but you have some time. I would start now. If you use the time you have in class right now, you'll get it done. Can you do what?